Okay, so I have to talk in English. Hi, once again. My name is Željko. I am an Android developer here at Infinum, and I work in our remote office in Slovenia. And I'm here today to talk about my favorite subject, and that's caching. Yeah, and to be more precise, how to cache like a boss. So, for the beginning, let's ask ourselves a stupid question. Why should we even cache anything in our applications? And the answer for that is really simple. Because by caching your data, your application data, you can provide better user experience. By caching, you are actually decreasing the number of network calls which are executed by your application. So basically, you are preserving mobile data package of your users, and you are making your applications accessible to work in offline mode. You need to understand the fact that not all of your users will actually use your applications when they are connected to Wi-Fi or when they have some quick connection or some slow connection. And let's say one example of that would be that if you are developing an application for airports or travel agencies, boarding passes should always be available offline, because you can't expect that all of your users will have internet connections on the airport and stuff like that. So cache all the things which you can cache in your apps. But things quickly tend to get a lot complicated, because not all the data which is generated inside of your application is equal. Not all caching mechanisms are equal, which are provided by Android OS. Each caching mechanism is suitable for only a part of your data. So you can store, you can, but it's not a great thing to, store, let's say, authentication tokens as plain text in your shared preferences. And the last thing, caching is slow. If you use in-memory cache, disk cache, database, it really doesn't matter. Caching is slow. You need to be aware of that. You need to know that if you are performing caching in synchronous actions, that they will block your UI. And the best thing to avoid is that if you think of your caching process as a network operation. So when you cache anything or fetch anything from cache, it has to be migrated to some background thread. The results has to be posted on main thread. And by using this approach, you will quickly find out that caching is pretty much the same thing as obtaining results from some server or stuff like that. Android provides us with different caching concepts, strategies, components, and stuff like that. And today we will be talking about response caching with OKHTTP, session objects, LRU cache, disk LRU cache preferences, and databases. So let's move to the first component. So the first thing is caching responses by using OKHTTP or some other web client library. We prefer to use OKHTTP. It's de facto standard today. It has a lot of great features, a lot of great models, and one of the awesome features is that you can add custom headers to your network calls, and you can add cache control headers, which will basically cache the network response somewhere on your file system. You need to provide a path. You can define what is the time span of that cache. So let's say that we want to cache all the network responses in the next 3 hours. And this is quite good thing. It's fascinating how much you will decrease the number of API calls just by caching the responses which are from the API calls which you call regularly from your application. This, let's say, component has, let's say, two major advantages and two major disadvantages. The first thing but from the advantage is that the implementation is really simple. You just add cache control header to your OKHTTP client. You can either add this header to individual API call, or you can define, let's say, some global interceptor which will add this header to all of your network requests. The next thing is that your retrofit callbacks, which you usually use in combination with OKHTTP, will be called the same way if you're actually getting the result from the cache or if you're getting the result from the server. So unsuccess and unfailed callbacks will be called in the same way. But it also has two major disadvantages. The first thing is that obviously this only works for network responses. So you can't cache data which is locally generated by your application. Let's say that I generate some data about user profile which I want to cache in my local storage, and I can't use this approach. So this only works on network responses. And the second disadvantage is that obviously this you should only use response caching for some API calls. So if your API responses are constantly changing, then there is no way and no need to cache it. So basically you just use this approach with API responses like statuses, enums, and let's say some data which you expect not to change drastically, which in that time span on which your cache control header is defined. Okay, so that's the first thing. The second component is session object. Session object is something what is quite familiar with in the web development. So basically you just use some Pojo Java class for data storage. It has to be singleton, so in most cases we don't want to have multiple session objects. We can have them, but that really complicates our flow, our data, and it's best to have a singleton object. You need to provide by app components from Dagger 2 so that this session is available, this object is available throughout the application by just injecting it. And the main difference between session object and all other caching components is that session object can have shorter life cycle than app life cycle. So let's say that we have a session object in which we want to store authentication token and some user-specific data which has to be added to each network request which is executed in the private part of your application. So let's say that we have some application, we have the public part which is available for anyone, and you have private part for which you have to log in and get the user credentials and stuff like that. So at first we start the application, we're in public part, everything works okay. Then we go in the private part, we log in with our user, we obtain the authentication token and some user profile data, which is then stored in session object. While you are in that private part of the application, you are using the data which is stored in session, and when your user clicks on logout button, you delete this object. So in most cases it has shorter life cycle than app life cycle. As we are using it to store sensitive user data. So this is something which should only be available in memory, like authentication tokens for network requests. And in most cases, we really don't want to store it on file system. But if for some reason we have to do it, you need to take into consideration what kind of data you're actually storing. So if it's authentication tokens, then you shouldn't even store it. If you have some sensitive user profile data, then you need to use some strong encryption before caching it, let's say, in shared preferences. But I would really suggest that if you have to cache session objects on your file system so that this object is available when you restart the application, probably you're doing something wrong. So sessions should only be used as in-memory objects. Moving on, LRU cache. LRU cache is a memory cache which holds strong references to a limited number of values. It's basically, let's say, a simple key value storage. But the main difference between LRU cache and all the other caching strategies and components is that it has a limited space requirement, and as it's in memory, it's deleted on app restart. We want to focus on this sentence, so it has limited space requirement. What this actually means? This means that when you initialize the LRU cache, you have to provide its size, and if when you add something to LRU cache, it's moved to the head of the queue, and when the queue is full, the objects and the data which is stored at the end of the queue is deleted. It can be evicted, and this is something what can cause a great pain if you don't realize that fact. So it's limited in space. If you want to store anything inside when it's full, the data which is at the bottom will get evicted, deleted, and then you're screwed if you didn't handle that. LRU cache is really fast because it works, as I said before, in memory. We usually use it to store bitmaps and icons which are downloaded from the web. So if you take a look at Picasso or Glide implementation, the first thing is that they cache the data on LRU cache, so that's that set memory cache, and afterwards for this caching they use disk LRU cache or some other components. And also we can use it to store some data which is not user sensitive. So basically, let's say that in session we want to hold the data which is like authentication tokens and stuff like that, but in LRU cache we can store some other data like, I don't know, list of something beautiful, Ivan Kotsian's pictures or stuff like that. Then we have disk LRU cache. It's quite similar to LRU cache, but this works on file system. So basically it's not in memory, it's stored somewhere on the disk. The concepts are pretty much the same, and if you want to use disk LRU cache, please use Jake Wharton's implementation because it's the best. Then we have preferences. Preferences are used for storing primitive key value pairs. So like if you want to store integers or strings or stuff like that. The great thing or the bad thing about preferences is that it can be either private or it can be shared or public. This means that if they are private, the preferences are only accessible inside of your application. But if you say that they are public, that actually means that some other application can access that data. By default, all the preferences are private. If you want to use public preferences, you can define that they are either only available in read mode, so that some other application can just access the data and read it. But you can also grant write privileges, and that's something what you don't really want. And preferences are stored on file system. And here we're gonna stop. In most cases, we tend to use preferences instead of databases. Why? Because they are simple. They are key value storage. You just put something to the shared preferences. When you need that data, you obtain it and it's there. You don't have to care about database schema. You don't have to care about primary keys, foreign keys, threading, blah, blah, blah. And we like to use preferences. And that's wrong. Let's consider a simple sample or code snippet. So let's say that we have a list of 5,000 objects, and each of that object, let's say that it has, I don't know, 20 properties or something like that. Those items can either be somehow connected or not, and because we are lazy, we will say that we want to store it in preferences. So every time when you store it, though that list actually has to be deserialized to string by using JSON or Jackson or something like that, and then you store it in your preference file. Which is, as I said, time consuming, because if you have to deserialize something, you need this operation will actually take some time. And afterwards, let's say that we want to obtain an item from that list by its ID. At first, we have to load that data from the file system in memory. We have to deserialize it with JSON to list, and then we have to iterate through all of the list to get that data. Here you are in danger for getting out of memory exception if you are using some device which has low and cheap hardware, and also this is time consuming. All of this can be avoided just by using databases. So preferences are really simple for use. They have really simple implementation, but please consider what kind of data you actually want to store into them. So the last thing are databases. Android has native support for SQL relational database. It's called SQLite. But you can also use NoSQL libraries from third-party providers like Realm, Firebase, Couchbase, Lite, and so on and so on. And also want to stop here because I want to say something about Realm. Realm is getting really, really popular in the last few months, and it's actually a great tool. It works really fast. It fixes some basic problems with SQL Lite database, but the thing is that Realm is not relational database. Realm is actually NoSQL database which has some, let's say, JSON storage mechanism, and if you start using Realm, that data is cached in NoSQL database, and at some point you say, okay, Realm maybe doesn't have some feature, or it's not working okay with me. I want to use dbflow, and you will have a lot of problems with your migrations. Because as I said before, Realm is NoSQL database. Android by default has support for SQLite, which is an SQL relational database. So if you're using Realm, Firebase, Couchbase, Lite, they are great tools, they are great databases, great libraries, which will solve some problems, but please take into consideration that if for some reason you will have to migrate to some SQL ORM, you will have a lot of problems with migrating your data. And why are databases great? Because if you use databases, you have full database supporting actions. So you can define database schema, you can use transactions, you can use CRUD actions for your models. Those models or tables can be connected by themselves by using primary key or foreign key. You have full support for migrations from older version to newer version. And databases can be copied, deleted, exported, and so on. But databases are slow. Each database is slow. If you use some kind of an ORM library, those actions will be even slower. And at this point, you have to take into consideration multi-threading, async execution, transactions. What happens if we have 3 different actions and one of them fails? And also from my own experience, we tend to have a lot of problems with database migrations. So let's say that with new version we introduced a new table, or we have changed the database schema of the existing table. If we don't write migration files in correct order, they will crash your application. So there's no way that a failed migration will not crash your application. And migrations are actually quite hard to debug because you're not working with Java code, you're using with SQL code, and you tend to have a lot of problems with that. But as I said before, the main advantages are full database support. You can copy your database from some web server to your local SQLite and stuff like that. So, how and when to use those components? Well, actually, it really depends on your use case. So as I said before, response caching should be used when we want to cache some data from the server which doesn't change regularly during some time. Session objects are usually used for storing sensitive user data inside user session, like authentication tokens and stuff like that. LRU cache should be used for storing data in memory, which you are constantly using in your application, and you want to get it really fast from the storage, like icons in your list views or cycler views, or I don't know, some data which you have to populate somewhere. Disk LRU cache should be used when you want to make data which are stored in LRU cache persistent, and you want them to be accessible between two app restarts. Preferences should be used for storing simple key value pairs. So don't store lists in preferences. Don't store anything which has connected components. That should be stored in database. So databases are used when you have like a complicated database schema, but then you have to know that things will get a little bit slower than before. And that's pretty much everything what I want to talk about today. So cache everything. If something goes wrong, Google it. DBFO is the best ORM library, and that's everything from me. So if you have some questions, now would be a good time.
You mentioned we should encrypt sensitive user data. Do you have any guidelines on how to do this properly?
Guidelines. Use strong encryption. Yeah,
but for example, if I encrypt a piece of data, obviously the key with which I encrypted the data will be in the APK. What's stopping the user from decompiling the APK and retrieving the key?
Well, the thing is that you can never have full security of your data. So you can encrypt it, but this doesn't actually mean that no one can decrypt it at any point of time. If data is encrypted, you still need to have a rooted phone to actually access the data. And if you are using some strong encryption, the user will need at least some time to penetrate this encrypted data, but everything is possible. The best way for that is if you really have some heavy sensitive data, which you don't want which you don't want to be accessed, like let's say your password for Facebook, because you are cheating your girlfriend, don't store it. That's actually something which should not be stored at any point of time in your application. Sensitive user data should just be used as in-memory caching mechanisms. Every time when you cache something to some file system or something like that, you are risking security problems. So use strong encryption, but if someone has the necessary tools, and he will penetrate it at some point of time. Maybe not today, but maybe in a few months.
Okay. Just to expand on the conversation here, what password managers usually do, they require you to input the password every time when you want to unlock something secure in the app, so they don't have to put the key in the app itself because it can be decompiled. But that's a special use case.
So as I said, passwords should not be encrypted. Authentication tokens, no. If you Google, should I cache Facebook authentication token, you will get at least 1 billion results where you will be hated just by asking that. So tokens are, in most cases, they change during the time. There's no need to cache them, and if you're caching them, then, well, it's just up to you. And
does that mean that I log out the user every time he closes the app?
No, because actually Facebook handles that. So if you use the current API, if the authentication token is still live, they will let you use the application without that login screen. But if the token is not live at the moment, you'll have to log in once again. More questions?
Why do you hate Realm?
No, I don't hate Realm. I think that it's a great software which fixes some problems. It's really, really fast, but it has some concepts and some APIs which are in my opinion bad, but they are trying to fix them. Like in up to a few versions before, you had to extend Realm object if you want to store PostgreSQL class in the database, and if you generated getters and setters, they just served as proxy methods to Realm getters and setters. So you couldn't use them. You just had to generate them, but if you wrote anything inside getter or setter, because I know you wanted to format some data, this was actually never called. They still have problems with multi-threading, so models cannot be shared between different threads and stuff like that, but they are getting better and better with each version, and I really believe that in next few months they will be ready for production, because they are still in, I think that they are still in beta with Android version, and when they will be ready, I think that it will be a really, really good product. More questions? Anything?
Thank you.
Okay. That's it.